Most people know Sir Isaac Newton as the genius who explained gravity, invented calculus, and transformed physics forever. But behind the public image of a brilliant scientist was a far more complex and hidden side, a side that reveals how curiosity, secrecy, and an endless hunger for knowledge shaped one of the greatest minds in history. Newton lived in a time when science was still emerging from the shadows of mystery and tradition, and he moved between these worlds with unusual confidence. Many assume that he spent all his life focused only on mathematics and physics, yet his private writings paint a very different picture, one filled with questions about nature that stretched far beyond ordinary science. When we think of Sir Isaac Newton, we usually imagine a scientist who shaped the modern world with ideas that still define physics today. The laws of motion, universal gravitation, calculus, and pioneering work in optics. These achievements are so monumental that they overshadow almost everything else he ever did. But what many people do not realize is that Newton devoted far more time, energy, and effort to alchemy and the hidden sciences than to the subjects for which he is most famous. For nearly 30 years, Newton worked secretly on alchemical manuscripts, coded letters, cryptic recipes, and experimental attempts to understand the internal structure of matter in ways that combined early chemistry with mystical philosophy. This private world reveals a side of Newton that was both intensely curious and deeply unconventional. To understand why Newton was fascinated by alchemy, we must look at the historical context. In Newton's time, the word alchemy did not simply mean turning ordinary metals into gold, although that idea was certainly part of it. Alchemy was a broad and complicated field that mixed experimental chemistry, natural philosophy, ancient traditions, and symbolic representations of nature. It was not just a search for wealth, but a search for hidden knowledge about how matter works. Alchemists believed that understanding the transformations of metals could reveal universal secrets about creation, decay, purification, and the forces that shape the physical world. In a way, alchemy was an early attempt to uncover the laws of nature long before modern chemistry existed. Newton approached alchemy with the same seriousness he brought to mathematics and physics. He collected hundreds of manuscripts, some from famous alchemists like George Starkey, some from obscure writers whose works barely survive today. Newton copied long passages by hand, annotated them with observations and questions, and tried to decipher symbolic diagrams that alchemists used to hide their ideas from the untrained reader. Many alchemical texts were intentionally mysterious, filled with metaphors about dragons, lions, suns, moons, and mythical creatures. These were not meant to be taken literally. Instead, each symbol represented a process or substance in nature. Newton studied these symbols carefully, trying to decode the underlying meaning. His notebooks reveal a scientist who was not merely curious but deeply dedicated to solving alchemical problems that others had abandoned. For example, Newton spent years analyzing the meaning of the green lion, a symbol commonly associated with a substance that could eat the sun. This was not actual sunlight, but a metaphor for a chemical reaction strong enough to dissolve gold. Newton wanted to understand the process behind this symbol. What substance, what reaction, what hidden principle made such transformation possible? His interest was not in magical thinking, but in discovering the real chemistry hidden behind ancient words. In the laboratory, Newton conducted experiments with remarkable precision for his time. He heated metals, distilled acids, evaporated salts, and observed how different materials behaved under changing conditions. Much of this work was dangerous. The chemicals he handled included mercury, antimony, lead, and arsenic substances we now know to be toxic. Yet Newton was fearless. He believed that every experiment, every observation, brought him closer to unlocking the secret mechanisms of nature. Newton's approach to alchemy was far from the stereotype of a wizard mixing potions. For him, alchemy was a way to understand the deeper laws that govern matter. He believed that the universe was not governed by randomness, but by precise causes and hidden forces that he hoped to uncover through careful study. In many ways, alchemy served as his training ground for scientific thinking. The idea that invisible forces could act at a distance, which he later developed into the law of universal gravitation, may have been inspired by alchemical ideas about attraction and repulsion between particles. Many modern historians believe that Newton's experiments with alchemy helped him develop concepts that later became part of physics. For instance, alchemists believed that metals grow inside the earth, transforming from one form to another. This idea of transformation influenced Newton's thoughts about change in physical systems. Similarly, alchemists wrote about invisible spirit forces that made matter behave in specific ways. Newton did not accept these ideas without question, but he explored them as possibilities. The very act of considering invisible forces may have helped him imagine gravitational attraction, which cannot be seen directly yet affects everything in the universe. A major reason Newton kept his alchemy secret was the social environment of his time. In the 1600s, alchemy had a questionable reputation. Some saw it as a legitimate pursuit of ancient wisdom, while others viewed it as superstition or fraud. Publishing alchemical work could damage one's professional standing, especially for someone like Newton, who was already emerging as a leading thinker in mathematics and science. Academic institutions were suspicious of anything that seemed mystical or irrational. Newton feared that revealing his interest in alchemy might lead people to dismiss his scholarly work. There was also a political danger. In England, alchemical experiments were sometimes associated with attempts to produce counterfeit gold. Because of this, the government carefully monitored alchemical activity. Newton, who later became the warden of the Royal Mint, was fully aware of this risk. Publishing an alchemical paper could lead to accusations that he was trying to make real gold, something illegal at the time. For these reasons, he locked away his alchemical notes, wrote in code, and shared his findings with only a few trusted friends. Yet despite this secrecy, Newton took alchemy very seriously. He believed that nature was filled with hidden mechanisms that could not be understood through mathematics alone. Alchemy offered a way to explore these mysteries. It was a field that encouraged experimentation, imagination, and deep questioning, all qualities that defined Newton's scientific personality. To him, alchemy was not a distraction, but a necessary part of understanding the natural world. One of Newton's most notable alchemical pursuits was his search for the philosopher's stone. This legendary substance was believed to purify metals, heal diseases, and reveal hidden truths about matter. While some alchemists interpreted it literally, Newton seems to have viewed the philosopher's stone as a symbol, a representation of the universal principle that governs all processes of change. He was less interested in creating gold and more interested in discovering the underlying principle that allowed transformations to occur. This search was not unlike his later work in physics, where he looked for universal laws that could explain the behavior of planets, objects, and light. Newton's alchemical manuscripts contain a mixture of observations, hypotheses, and questions about the structure of matter. He believed that metals were composed of sulfur and mercury, not in the literal sense, but as fundamental principles. These ideas may seem strange today, but they were early attempts to describe atomic structure. While Newton did not have modern chemistry or atomic theory, he was trying to answer similar questions. What is matter made of? How do its parts interact? What invisible forces shape its behavior? Alchemy gave him a language for exploring these questions long before modern science developed its own vocabulary. Newton's fascination with alchemy also shaped his personality. It reinforced his tendency towards secrecy, his preference for working alone, and his belief that knowledge must be protected until fully understood. Alchemy provided a safe intellectual space where he could explore unconventional ideas without the pressure of public judgment. This freedom allowed him to think more creatively and to experiment with concepts that would later influence his scientific breakthroughs. Another important aspect of Newton's alchemical work is the sheer volume of material he produced. Modern scholars estimate that he wrote over 1 million words on alchemical topics, far more than he wrote on physics or mathematics. These writings reveal a man who was deeply engaged, constantly thinking, constantly experimenting, and always searching for deeper truths. Newton's alchemical notebooks are filled with diagrams of laboratory equipment, detailed instructions for mixing and heating substances, and carefully recorded results of experiments. He left behind extensive studies of metallic behavior, color changes in chemical reactions, and the effects of heat on substances. These observations helped him develop a sharp sense of experimental discipline. His work with prisms and light, for example, required careful control of conditions, precise measurement, and repeatable testing, all skills he practiced in alchemy. Without his years in the alchemical laboratory, he might not have developed the methodology that led to his groundbreaking discoveries in optics. Some people today wonder whether Newton truly believed in the mystical aspects of alchemy. The truth is complicated. Newton was interested in the spiritual and symbolic dimensions of alchemy, but he always tested ideas through experiment and reason. He rejected theories that lacked practical evidence. His pursuit of alchemy was not based on superstition, but on the belief that ancient wisdom contained fragments of truth that could be uncovered through careful study. He saw alchemists as early natural philosophers who attempted to describe nature using the tools available to them. Newton believed that by decoding their symbols and combining them with modern scientific methods, he could uncover the laws that governed the physical world. Newton's fascination with alchemy also connected to his interest in theology. He believed that God created the universe according to rational laws, and that by studying nature, one could better understand these divine principles. Alchemy, with its emphasis on hidden structures and processes, seemed to offer a deeper glimpse into the design of creation. Newton viewed his scientific work as a form of spiritual inquiry. He believed that discovering the secrets of matter was part of understanding the greater order of the universe. As we explore Newton's hidden world of alchemy, it becomes clear that this was not a side hobby or curiosity. It was a major part of his intellectual life. It shaped his thinking, influenced his experiments, and guided his search for universal principles. Newton's fascination with alchemy reveals a man who refused to limit himself to accepted knowledge. He wanted to explore everything, from mathematics to metaphysics, from chemical reactions to cosmic forces. His alchemical work demonstrates how broad his curiosity was and how deeply he believed that truth could be found in unexpected places. Today, scientists do not follow alchemy as Newton did, but his work in that field remains historically important. It shows that the path to scientific discovery is not always straightforward. Sometimes it involves exploring ideas that later generations may reject or reinterpret. Newton's willingness to investigate the hidden sciences demonstrates his fearless pursuit of knowledge. He did not care whether an idea was fashionable, conventional, or controversial. If there was a possibility that it could reveal something about nature, he pursued it with full dedication. In studying Newton's alchemy, we also learn something important about the nature of creativity. Newton's breakthroughs in physics were not isolated events. They grew out of years spent experimenting, observing, and thinking about the invisible forces that shape the world. His alchemical work provided him with a rich foundation of ideas, tools, and mental frameworks that he later adapted into scientific principles. The secret side of Newton, his fascination with alchemy and hidden sciences, was not separate from his scientific achievements, but deeply connected to them. This secret world shows Newton as a thinker who embraced uncertainty, mystery, and complexity. Freeing, your CLOTCHEEPTED, without S from his Grot. Whether in the laboratory, the library, or his private study, Newton was always searching for deeper explanations. His fascination with alchemy reveals the full depth of his curiosity and the extraordinary range of his intellectual passion. To continue understanding Newton's fascination with alchemy, it's important to recognize that he saw the world as a delicate balance between what is visible and what is hidden. In mathematics, he looked for the invisible rules beneath observable patterns. In physics, he described the invisible force of gravity shaping the motion of planets. In optics, he uncovered the invisible structure of light. Alchemy fit perfectly into this pattern. It was a study of hidden transformations inside matter changes that could not be seen directly, but could be revealed through careful experimentation. Newton believed that if he could understand these transformations, he could uncover the deepest truths about nature. One of the most striking aspects of Newton's alchemical work is the incredible patience he showed. Alchemical experiments often required slow, multi-step processes. Heating substances for days, waiting for materials to dissolve, drying mixtures at carefully controlled temperatures, and repeating procedures over and over to confirm results. Newton's notebooks show a person willing to spend months on a single experiment, making small adjustments and documenting every detail. This patience and attention to detail were rare even among alchemists. It also explains why he was able to master complex, scientific problems later in life. Newton trained himself to think slowly, carefully, and deeply, skills that would later allow him to discover the laws of motion and universal gravitation. Many of Newton's experiments dealt with metals, how they reacted to heat, how they combined with other materials, and how they changed color or form over time. Alchemists believed these changes reflected deeper processes, such as purification or corruption. Newton took this seriously. He noted how different metals melted, how they separated when mixed, how they burned when exposed to certain vapors, and how their properties differed depending on their preparation. In an age before modern chemistry, these observations were extremely advanced. Newton did not use microscopes or molecular models, but he used his eyes, hands, and mind to detect patterns in the behavior of matter. Some scholars believe that Newton came closer to modern chemistry than any other alchemist of his time. For example, he understood that chemical reactions depended on the proportions of substances, not just their presence. He recognized that heat could break apart compounds, and that some reactions depended on the presence of invisible vapors. He recorded the formation of alloys, the behavior of volatile chemicals, and the unexpected colors produced by certain reactions. He may not have known the periodic table, but he was building an early understanding of what we now call chemical properties. Newton's fascination with alchemy also reflected his desire to unify different fields of knowledge. For him, there were no strict boundaries between mathematics, physics, theology, and chemistry. He believed that truth was a single interconnected whole. If he discovered a law in astronomy, it might help him understand a process in chemistry. If he decoded a symbol in an ancient manuscript, it might reveal something about the structure of matter. This unified approach made Newton unique. While most scholars focused on one subject, Newton studied everything he could get access to, always looking for the hidden connections that tied the universe together. Some historians describe Newton as a natural philosopher rather than a scientist because the word scientist did not exist during his lifetime. Natural philosophers asked big questions. What is the universe made of? What forces move celestial bodies? What is the relationship between matter and spirit? Newton's alchemical work shows that he asked these questions not only through equations and observations, but also through experiments that explored matter on the most fundamental level available to him. Alchemy gave him a way to test ideas that mathematics alone could not answer. One of the most important themes in Newton's alchemy is the idea of active principles. Newton believed that matter was not passive. It did not simply sit still. It could interact, combine, separate, attract, and repel. These ideas would later become the foundation of his physical theories. When he introduced the concept of gravitational force acting at a distance, many of his contemporaries criticized him. They argued that matter could not exert force without touching. But Newton had spent years studying alchemical texts that described invisible interactions between particles. He had observed chemical reactions where substances acted upon each other without physical contact. These experiences made it easier for him to imagine invisible forces governing the universe. Newton's private manuscripts show that he believed matter contained spirit, like components, forces that acted at a distance, causing changes in physical form. He did not mean spiritual in a religious sense, but rather invisible principles that carried out natural processes. This idea helped him develop theories about gravity, light, and motion. While he did not publish these alchemical ideas, they influenced his thinking. His mind was trained to imagine forces that could not be seen directly, but could be felt through their effects. Newton also studied ancient myths and texts that connected alchemy to the origins of the universe. He believed that ancient cultures possessed fragments of scientific truth hidden in symbolic language. If he could decode these symbols, he might uncover knowledge that had been lost for centuries. This belief drove him to collect and translate rare manuscripts. He studied Greek, Hebrew, and Latin writings that described creation, matter, and natural transformations. Many of these texts were mystical or philosophical, but Newton treated them like scientific documents. He believed the ancients may have understood natural laws that later civilizations forgot. One example is his study of the Emerald Tablet, a legendary text attributed to Hermes Trismegistus. The tablet supposedly described the fundamental principles of creation, transformation, and unity in nature. Alchemists throughout history referred to it as a key to understanding the secret fire, or the hidden force that drives natural processes. Newton translated the text and wrote notes analyzing its meaning. He was convinced that the tablet contained clues about the laws that govern matter. This effort shows how deeply he valued the symbolic side of alchemy. He believed symbols were not decorations, but tools for conveying meaning across generations. Newton's interest in alchemy also shaped his personality in profound ways. Because he studied alchemy in private, He developed habits of secrecy, caution, and introspection. He preferred to work alone without interference. He trusted only a handful of people with his ideas. Even when he discovered something groundbreaking, he sometimes waited years to publish it. This was partly because he feared criticism, but also because he believed knowledge should not be shared casually. In alchemy, revealing too much to the unprepared could be dangerous or irresponsible. Newton carried this mindset into his scientific work. Newton's secrecy also created mysteries that scholars are still trying to solve. For instance, some of his alchemical notes appear incomplete or cut off. Others are written in cryptic symbols or coded language. Historians have had to reconstruct his notebooks from fragments found across Europe. Many of his alchemical manuscripts were auctioned off long after his death, scattered among private collectors, and only recently brought together for study. Each new discovery reveals more about how he thought, experimented, and imagined the workings of nature. A common misconception is that Newton's alchemy was irrational or unscientific. But when we study his writings closely, we see a rational mind applying systematic methods to a field that lacked modern tools. Newton measured, observed, categorized, repeated experiments, and looked for patterns. He rejected ideas that failed to produce results. He used logic and experimentation, not guesswork or magic. He believed that nature obeyed rules and that those rules could be discovered through careful study. Alchemy may not be considered science today, but Newton approached it with the same discipline that helped him revolutionize physics. His work also shows how closely related alchemy and early chemistry were. The two fields shared tools, methods, and goals. Many early chemists, including Robert Boyle, another pioneer of modern science, also practiced alchemy. Boyle believed that alchemists had discovered valuable information, but had hidden it behind symbols. Newton agreed, and he spent years trying to extract those ideas. While modern chemistry would eventually break away from alchemy, it still owes much to these early experiments. Newton helped create a bridge between the mystical past and the scientific future. One of the most intriguing questions about Newton's alchemy is how he balanced it with his more public scientific work. During the same period when he was developing calculus and studying planetary motion, he was also conducting alchemical experiments late into the night. His schedule was intense. He often forgot to eat or sleep. His letters suggest that he sometimes stayed in his room for days without speaking to anyone. The laboratory became a place where he could test ideas that were too speculative for public discussion. Mathematics provided him with certainty, while alchemy allowed him to explore the unknown. Some people have wondered whether alchemy drove Newton to extreme behaviors. While we must avoid harmful speculation, it is clear that he was passionate, intense, and often consumed by his studies. He saw knowledge as a treasure worth pursuing at any cost. His dedication was remarkable, but also demanding. Newton believed he was uncovering secrets that ancient philosophers had guarded for centuries. This sense of mission may have motivated him to work tirelessly, sometimes at the expense of his own comfort. The most surprising part of Newton's alchemical research is how modern it sounds in some places. He speculated about particles too small to see, forces that act at a distance, and the idea that matter could be transformed by altering its internal structure. These ideas would later become central to modern physics and chemistry. Newton lacked the tools to test these theories properly. Microscopes were primitive, chemistry was undeveloped, and atomic theory did not yet exist. But his imagination was ahead of its time. He believed the universe was dynamic and interconnected. Matter was not static, but alive with movement, forces, and potential transformations. Newton's fascination with alchemy also tells us something important about the nature of discovery. Great breakthroughs do not always come from the most obvious sources. Sometimes they emerge from unexpected places, from ideas that others dismissed or misunderstood. Newton's willingness to explore alchemy shows that creativity often requires moving beyond conventional boundaries. By studying a field considered strange or controversial, he gained new perspectives that enriched his scientific work. If Newton had never studied alchemy, he might still have become a great scientist, but his ideas might have been narrower. Alchemy encouraged him to think about matter in new ways, to imagine unseen forces, and to look for patterns in complex processes. It helped him develop a world view in which everything was connected by universal laws. This world view allowed him to see connections between falling apples and orbiting planets, between light passing through a prism and colors forming in a flame, between the behavior of metals and the behavior of stars. Newton's alchemy also reminds us that science is a journey, not a straight line. The path to understanding is often messy, filled with detours, mistakes, and unexpected discoveries. Newton explored everything, even ideas that would later be rejected, because he believed every question was worth investigating. His openness to exploring hidden sciences made him a more flexible and imaginative thinker. In the end, Newton's fascination with alchemy is not a curiosity or a contradiction. It is a key to understanding who he truly was. He was a seeker of truth in all its forms, a person who refused to accept the limits of conventional knowledge. He believed that the universe held secrets waiting to be uncovered, and that it was his duty to search for them, wherever they might be hidden. Whether he was studying the motion of planets or the behavior of metals, Newton approached the world with a deep sense of wonder. Alchemy represents the part of Newton's mind that was always reaching for deeper explanations. It shows his courage in exploring ideas that others feared or ridiculed. It reveals his belief that the natural world was filled with mysteries that required imagination as well as logic. It highlights his desire to uncover the hidden architecture of reality. Today, Newton is remembered as one of the greatest scientists who ever lived. But to fully understand his genius, we must also understand the secret side of his life, his passion for alchemy and hidden sciences. This passion shaped his methods, influenced his discoveries, and fueled his lifelong search for truth. It reminds us that curiosity has no boundaries, and that even the greatest minds must sometimes explore the unknown to reveal the laws that govern the universe. When we talk about Sir Isaac Newton, we often celebrate him as a pioneer of physics, mathematics, astronomy, and optics. But beneath the surface of his scientific achievements was a deeply personal, carefully guarded world of religious study and theological inquiry, an area of his life he deliberately kept hidden from much of the public. Newton's private writings reveal that he spent more time on religious questions than he did on mathematics or physics. In fact, scholars estimate that he wrote more than 1,000,000 words on theological topics. This huge intellectual investment shows how central religion was to Newton's worldview. To understand Newton's secret religious side, we need to begin with the environment in which he lived. Newton's England was a place where religion shaped politics, society, education, and personal identity. The 1600s were marked by religious tensions, the English Civil War, conflicts between Catholics and Protestants, and disagreements within Protestant theology. Any deviation from accepted doctrine could be dangerous, intellectually, socially, and even physically. Religious views were not merely private beliefs, but political positions that affected one's place in society. Newton was aware of this environment and took great care to keep his most unorthodox ideas private. He lived in an era where questioning certain doctrines could result in accusations of heresy, persecution, or the loss of academic positions. Because of this, Newton hid many of his theological writings in coded notebooks, private letters, and unpublished manuscripts. He recorded his views in ways that only he, or a few trusted individuals, could understand. This sense of secrecy shaped the way he studied religion and influenced how we understand him today. One of the most significant aspects of Newton's theology was his rejection of the traditional Christian doctrine of the Trinity. The Trinity, the belief that God exists as Father, Son, and Holy Spirit in one being, was, and still is, a central doctrine of mainstream Christianity. In Newton's time, denying the Trinity was illegal. It was considered heresy under English law. People who openly opposed it could lose their positions, be imprisoned, or worse. Newton understood the risk and kept his beliefs hidden. His private writings show that he spent years carefully examining the Bible, early church writings, and historical documents. He concluded that the doctrine of the Trinity was a later invention, not part of original Christianity. Newton believed that Jesus was the Messiah and a divine figure, but not equal to God the Father. This view aligned with a theological position known as Arianism, a belief system that had been declared heretical by the Church centuries earlier. Newton never used the word Arian to describe himself, but his beliefs closely matched the Arian position. Newton's rejection of the Trinity may seem abstract, but it shows how deeply he valued reason, evidence, and careful reading. Just as in his scientific work, he believed that true religion must be grounded in rational study, not tradition or authority. This reflects a key theme in his thinking. Newton did not accept ideas unless he had personally tested them through analysis, reading, and logical argument. Whether he was studying gravity, light, or scripture, he approached the problem with the same disciplined and critical mindset. Newton's religious writings also reveal that he saw himself as part of a long tradition of scholars searching for lost truths. He believed that over time, the original teachings of Christianity had been corrupted. His mission, in his view, was not to invent new doctrines, but to restore the purity of early Christianity. This restoration required immense effort, because Newton believed that the truth had been hidden inside ancient texts, complex symbols, and historical records that had not been properly understood. Newton, therefore, studied the Bible with incredible intensity. He wrote detailed commentaries on the books of Daniel and Revelation, 2 sections of the Bible filled with symbolic visions, prophecies, and apocalyptic imagery. These writings fascinated him because he believed they contained coded messages about history, morality, and the future. Newton applied mathematical precision to interpreting these prophecies, analyzing timelines, symbols, and historical parallels with the same careful reasoning he used in scientific problems. His theological manuscripts reveal a man who was constantly searching for the underlying structure of divine revelation. He tried to decode symbolic numbers, identify historical figures mentioned in prophetic visions, and trace the development of early Christian communities. He believed the Bible was not just a spiritual guide, but a carefully constructed document that preserved hidden truths about God's plan for the world. One of Newton's most ambitious projects was his attempt to determine the exact shape and structure of the ancient Temple of Solomon in Jerusalem. He believed that understanding the temple's architecture would reveal hidden truths about the universe, divine law, and spiritual order. Newton studied ancient measurements, compared manuscripts, analyzed traditional descriptions, and attempted to reconstruct the temple's layout in detailed diagrams. His notebooks include drawings of walls, courts, chambers, and altars, reflecting his deep belief that sacred architecture was an expression of divine design. Newton's religious curiosity was not limited to Christianity. He studied ancient cultures, myths, and philosophical traditions from Egypt, Greece, Babylonia, and the Hebrew world. He believed that many ancient civilizations preserved fragments of the same original truth. These fragments, scattered across different cultures, contained clues about the nature of God, creation, morality, and the laws that govern the universe. Newton saw himself as a detective, assembling these fragments into a coherent picture. At the center of Newton's religious world was the belief that God was not distant or passive, but actively involved in the structure of the universe. In Newton's view, the laws of physics were not just mathematical patterns, they were expressions of God's will. Gravity, motion, and light were part of a divine language written into nature. Newton once wrote that the study of nature was a way to understand the eternal and infinite being who created the universe. His scientific work was deeply connected to his spiritual beliefs. He believed that by uncovering the forces that governed nature, he was revealing aspects of God's plan. Newton also believed that God continually maintained the universe. He disagreed with thinkers who saw the universe as a giant machine that ran on its own without ongoing divine involvement. Newton believed that divine power was necessary to sustain motion, maintain order, and prevent chaos in the cosmos. This belief influenced his scientific theories. For example, he argued that the solar system required God's constant care to remain stable. Another fascinating aspect of Newton's theology was his moral rigor. He believed that God expected absolute moral purity from individuals. Newton kept detailed lists of his own actions, including even small mistakes, and judged himself strictly. His personal notes show deep introspection, self-discipline, and a belief in ethical responsibility. Newton's religious writings suggest that he viewed the search for truth, both scientific and spiritual, as a moral duty. He believed that God rewarded those who pursued knowledge with humility and sincerity. Newton's views on religion also shaped his relationships with others. He admired scholars who combined rational thinking with religious devotion. He disliked those who relied on superstition, authority, or emotional belief without evidence. Newton often avoided religious debates because he feared they would distract from the pursuit of truth. But he did sometimes express frustration with what he saw as corruption or irrationality in institutional religion. His letters reveal that he believed many churches had strayed from their original purpose. One of the most interesting questions about Newton's theology is whether it influenced his scientific discoveries. Many historians believe it did. Newton's belief in a rational and orderly God encouraged him to look for rational and orderly laws in nature. His belief that truth was often hidden encouraged him to search for underlying patterns. His habit of studying ancient texts for hidden meanings may have influenced the way he searched for universal mathematical principles. His commitment to rationality and evidence shaped the way he conducted experiments and developed theories. But Newton kept his religious writings private, not because he doubted them, but because he knew they challenged powerful institutions. His letters show that he feared being misunderstood or judged. This secrecy created a hidden world within his life, a world that scholars could only glimpse after his death, when his manuscripts were uncovered. Today, Newton's theological writings are considered valuable historical documents. They reveal the depth of his intellect, the complexity of his beliefs, and the rich inner life of a man who dedicated himself to understanding both the natural world and the divine. His religious writings challenge the modern stereotype of Newton as a purely rational scientist. Instead, they reveal a thinker who saw no separation between science and spirituality, one who believed that both were necessary to understand the universe. Newton's unorthodox theology shows us that he was more than a scientist. He was a seeker of truth in every possible form. He believed that the universe was a reflection of divine order, that human reason was a gift meant to uncover that order, and that true wisdom required humility, discipline, and dedication. His secret religious world adds a new dimension to our understanding of his legacy. It shows that the same mind that discovered gravity was also deeply engaged in questions about God, morality, prophecy, and creation. Newton's fascination with theology cannot be understood only through the surface-level fact that he studied religion. What makes this aspect so extraordinary is the depth, intensity, and originality with which he approached ancient writings. He did not study theology the way priests, scholars, or philosophers commonly did. He treated it as a massive intellectual puzzle, a hidden structure of history, symbolism, mathematical patterns, and linguistic codes waiting to be decoded. In Newton's mind, the universe created by God possessed an order and logic, and he believed that the same logic was imprinted onto sacred texts, historical events, and moral laws. This belief shaped the way he read ancient scriptures. He approached every sentence with microscopic attention, breaking down words, comparing translations, and analyzing connections between different books that most readers never noticed. He read manuscripts in Hebrew, Greek, Latin, and Aramaic. He compared early versions of religious texts to trace how meanings shifted over centuries. In this process, he discovered inconsistencies and layers of symbolism that fueled his suspicion that the original meanings of many religious ideas had been altered, lost, or misunderstood as time passed. Newton also placed immense importance on the idea of restoring truth. He believed that several ancient teachings had been corrupted by political disputes, copying errors, or power struggles within religious institutions. Rather than confronting or attacking the church directly, he quietly searched for what he believed were the earliest, purest meanings. His notebooks are filled with attempts to reconstruct timelines of ancient civilizations, dates of key biblical events, and interpretations of prophetic symbols. He treated history like a long chain of clues, each pointing to a deeper law of divine order. A unique part of Newton's theological approach was how he merged scientific thinking with sacred interpretation. For example, he believed that prophecies were not vague mystical statements, but precise descriptions encoded in symbolic language. He believed these could be deciphered logically, much like solving a complex mathematical problem. This approach was this unusual blending of method and meaning, bringing science into spirituality and spirituality into science. That set Newton apart from typical theologians. Another important dimension of Newton's hidden theological work involves his obsession with chronology. Newton did not simply accept traditional religious timelines. He recreated them from scratch. He calculated the ages of ancient kingdoms, examined the rise and fall of empires, and attempted to align these histories with events recorded in Scripture. He meticulously cross-checked ancient sources, such as the works of Greek historians, Roman records, and Middle Eastern texts. His goal was to build a single unified timeline of human civilization that connected secular history with biblical accounts. This was not an easy task. Many ancient texts contradict one another, but Newton attempted to resolve these contradictions with logic. For example, if two historical sources gave different dates for the same event, he would study astronomical references, the lifespans of rulers, or archaeological descriptions to determine which source was closer to the truth. He also believed that ancient civilizations shared common themes, flood myths, symbolic numbers, descriptions of astronomical events, and he interpreted these as evidence of shared origins or shared revelation. His instinct was always to search for underlying unity. Newton's studies of prophecy also took a central role in his private intellectual world. He analyzed the books of Daniel and Revelation with the same seriousness he applied to the laws of motion. To him, prophetic visions were not random images, but structured systems of symbols. For instance, he studied the symbolic use of animals, numbers, and colors, believing they represented real political or historical forces. He attempted to identify these symbols by matching them with historical kingdoms, events, and transitions. His notes show diagrams of empires rising and falling, timelines of religious controversies, and detailed interpretations of symbolic numbers. But Newton's theological studies were not detached academic pursuits. They were deeply emotional and moral. He believed that uncovering truth was a form of worship, and that God had designed the universe to be understood by human reason. He felt that discovering truth, whether through mathematics, physics, or scripture, brought him closer to the mind of the Creator. This belief gave him a lifelong sense of responsibility. In his view, truth was sacred, and he had to handle it carefully, humbly, and honestly. For this reason, Newton rarely published his theological work. He feared that his unusual conclusions would cause controversy or be misunderstood. He was deeply aware of how easily religious debates could turn dangerous in his era. He also believed that people who were not prepared to receive deeper truths might misuse or distort them. Thus, he preferred to keep most of his theological writings private, recording them only in his notebooks and sharing them with a few trusted individuals. Ironically, these private studies occupy millions of words, far more than he ever wrote about physics or mathematics. It is also important to understand how Newton's interest in ancient mysteries shaped his worldview. He studied not only the Bible, but also ancient mythologies, early pagan traditions, and classical philosophies. He searched for connections between the symbols of different cultures, believing that they all pointed to a single original truth that had become fragmented over millennia. He examined the architectural proportions of ancient temples, the measurements of the Great Pyramid, and the mathematical patterns embedded in early rituals. To Newton, the ancient world had preserved bits of universal knowledge in various forms, and he wanted to piece them back together. One of the most remarkable aspects of Newton's secret religious investigations was his belief that early knowledge had been expressed through a symbolic science. He believed that before writing systems became widespread, ancient sages used allegories, symbols, and myths to communicate deep truths. These included concepts about the creation of the world, the structure of the cosmos, and moral law. Newton believed that a wisdom tradition once existed, a body of pure knowledge given by God and preserved by a select few. Over time, this knowledge became buried under layers of superstition, politics, and myth. Newton's goal was to strip away these layers and retrieve the original clarity. His study of languages played a crucial part in this. Newton believed that words themselves were keys to hidden meanings. He examined the etymology of ancient terms, compared them across different cultures, and traced how meanings evolved. He noticed that many early words for light, order, or creation seemed connected across languages, which reinforced his belief in a unified origin of human knowledge. His linguistic notes reveal how carefully he studied variations in spelling, grammar, and pronunciation to understand what early writers truly meant. Newton's interest in the moral structure of the universe also influenced his hidden theological work. He believed that God had created not only physical laws, but also moral laws that governed human behavior. Just as planets followed predictable paths, he believed human societies rose or fell according to moral principles. This belief made him especially fascinated by the moral lessons of ancient texts. He studied them not simply as stories, but as patterns that could reveal why civilizations prospered or collapsed. He viewed morality as a natural law, not just a religious requirement. Another layer to Newton's secret theology was his desire to reconcile reason with faith. He lived during a period when many thinkers saw a growing divide between science and religion, but Newton rejected that division. To him, scientific discoveries were not threats to faith. They were confirmations of divine wisdom. By uncovering mathematical laws, he believed he was discovering the structure God had built into creation. This harmony between scientific and spiritual reasoning was one of the defining features of his thought. He felt no contradiction between studying gravity and studying prophecy, because both, to him, revealed aspects of the same divine order. Much of Newton's secrecy came from his understanding of how society might react to his conclusions. Some of his theological interpretations challenged widely accepted doctrines. Other interpretations involved ideas that were politically sensitive at the time. Newton was deeply cautious. He believed that a scholar's duty was to pursue truth, but also to avoid causing harm. This explains why he spent decades refining his interpretations without publishing them. He wanted perfect clarity before sharing anything, and he feared misunderstanding far more than criticism. Even though Newton kept this side of himself hidden, it shaped his scientific work in significant ways. His belief in order, harmony, and underlying laws inspired his search for universal principles in physics. His sense of moral responsibility influenced his careful method of investigation. His intense focus and discipline came from his feeling of being accountable to a higher standard. Newton saw himself not just as a scientist, but as a seeker of truth in all its forms. His scientific success cannot be separated from his theological world. One shaped the other. Another important dimension is the emotional aspect of Newton's faith. Though he lived much of his life in isolation, his writings reveal a mind that struggled with doubt, hope, humility, and a profound longing to understand the purpose behind creation. He wrestled with questions of destiny, the meaning of human life, and the nature of divine justice. His intellectual pursuits were deeply connected to his search for inner clarity. For him, studying theology was not just an academic exercise, but a journey of understanding the world and his place in it. Newton's theological manuscripts reveal his belief that knowledge required discipline, purity of thought, and sincerity of intention. He believed that arrogance, greed, or ambition could cloud understanding. This conviction deeply influenced how he approached all subjects. He avoided speculation and preferred direct evidence, whether in scientific experiments or scriptural analysis. This disciplined, almost ascetic approach shaped his entire personality and reputation. His colleagues saw him as reserved and intensely focused, but underneath that exterior was a man driven by both intellectual rigor and spiritual devotion. One of the most fascinating consequences of Newton's secret theological work is its impact on modern understanding of his legacy. For centuries, Newton was portrayed only as a rational scientist, the ultimate symbol of Enlightenment reasoning. But when his private manuscripts were finally examined in the 20th century, historians realized that this image was incomplete. The real Newton was not a purely rational thinker, but a deeply spiritual seeker, whose scientific achievements were only one part of his vast intellectual world. His unpublished writings revealed a man who believed deeply in a universe filled with meaning, purpose, and design. This discovery changed how scholars interpret Newton's life. It became clear that his scientific and theological interests were not separate, but intertwined. His search for universal laws in nature mirrored his search for universal truths in Scripture. His belief in cosmic order influenced his belief in historical order. His fascination with mathematical structures echoed his fascination with symbolic structures in prophecy. The hidden side of Newton was not a distraction from his scientific genius. It was the foundation that sustained it. Newton's theological work also reveals how open he was to questioning assumptions. He did not blindly accept religious traditions, nor did he reject them. He tested them, examined them, and reconstructed them using evidence. This method reflects the same intellectual courage he displayed in science, challenging old models, proposing new ideas, and searching for consistency. His willingness to question long-held interpretations demonstrates how deeply he valued truth over tradition, even when he kept his conclusions private. Another notable aspect of Newton's theological thinking is his belief that wisdom was timeless. He thought that ancient texts contained insights just as valuable as modern discoveries. Unlike many Enlightenment thinkers who dismissed the past, Newton respected it deeply. He believed that early civilizations possessed knowledge that was later forgotten or misunderstood. This belief motivated him to preserve ancient wisdom by decoding it, clarifying it, and integrating it with modern understanding. Newton's interest in prophecy also raised larger questions about the direction of history. He believed that historical events followed a pattern, and that by studying these patterns, one could understand how divine justice unfolded over time. This was not an attempt to predict the future in a mystical sense, but an attempt to understand the forces shaping human destiny. His interpretation of prophecy was grounded in history, politics, and moral law, not superstition. He saw prophecy as a reflection of the moral structure of the world, not as a magical secret. One of the greatest strengths of Newton's theological work was his ability to hold vast amounts of information in his mind at once. He connected linguistic details with historical records, symbolic interpretations with political events, and mathematical observations with philosophical ideas. This remarkable ability allowed him to see patterns that others overlooked. His theological manuscripts reveal a mind that could link small details with large structures, weaving them into a coherent understanding of the world. It is also important to realize how much personal effort Newton invested in these studies. He spent decades reading, analyzing, and rewriting. He filled thousands of pages with notes, diagrams, and reflections. This was not a hobby or side interest. It was a lifelong pursuit. Even when he was at the height of his scientific career, he continued working on theological questions in private. His dedication to these subjects reflects the depth of his curiosity and the seriousness with which he approached all forms of knowledge. Newton's private faith also shaped his ethical views. He believed strongly in honesty, humility, and self-discipline. These qualities defined his personality and his scientific method. They also influenced his decisions in public service when he worked at the Royal Mint. Newton viewed moral behavior as essential to the functioning of society. just as physical laws were essential to the functioning of the universe. This moral seriousness can be seen in how he approached everything, from correcting counterfeiters to analyzing scripture. Perhaps the most profound idea in Newton's hidden theological world was his belief in harmony. He believed that every aspect of creation, physical, historical, spiritual, was connected by underlying laws. These laws reflected the wisdom and character of God. Newton devoted his life to discovering these laws, whether through calculus, experiments, linguistic analysis, or historical research. His intellectual journey was an attempt to grasp the structure of creation, and theology was a central part of this structure. The secret side of Newton's theological studies ultimately reveals his unshakable belief in reason. He believed that God had designed the human mind to understand creation. He believed that truth could withstand scrutiny, that questions were not threats but opportunities, and that knowledge brought humanity closer to divine wisdom. This belief shaped his scientific discoveries and his spiritual reflections alike. The hidden side of Newton's theology is not just an interesting historical detail. It is a key to understanding the mind that reshaped the world. His pursuit of truth in all its forms, his courage to question assumptions, and his deep desire to understand the universe make his theological work as significant as his scientific achievements. Newton's secret studies reveal a thinker driven by wonder, discipline, and an extraordinary faith in the power of human reason. When people hear the name Sir Isaac Newton, they immediately think of gravity, calculus, or the laws of motion. But Newton's private notebooks reveal a very different portrait, one that few knew during his lifetime. Hidden away from public view for centuries, these notebooks contain some of the most unusual, bold, and mysterious experiments ever attempted by a scientist of his era. They show Newton not just as a physicist or mathematician, but as a restless explorer of nature who wanted to unlock every secret the world contained, even if those secrets lay far outside the boundaries of traditional science. Newton kept his experimental notes extremely private. Some of these notebooks were written in code, while others were filled with cryptic symbols and references so complex that even modern scholars struggle to interpret them. This secrecy was not accidental. Newton believed that sharing certain types of work, especially those dealing with alchemy or deep natural mysteries, could be misunderstood, criticized, or even dangerous. During his time, alchemy was often associated with superstition, secrecy, or forbidden knowledge. Yet Newton dedicated decades of his life to it, recording thousands of observations, laboratory results, and chemical experiments. One of the most fascinating aspects of Newton's notebooks is the sheer variety of experiments he performed. He combined careful scientific precision with the imaginative freedom of a philosopher-chemist. His experiments involved heating metals, observing color changes, grinding minerals, extracting oils, analyzing salts, and mixing strange compounds in search of transformations. Some notebooks contain diagrams of furnaces and instructions for constructing specific kinds of laboratory equipment. Others describe the behavior of substances under different conditions, how they reacted when heated, cooled, dissolved, or purified. Newton's goal was not simply to create new materials. He believed that matter itself held hidden principles, and he wanted to uncover these principles by studying how substances changed form. Alchemists of his time believed that metals and minerals had internal spirits, or active principles, that shaped their nature. While Newton did not accept every traditional alchemical idea, he did believe that nature had invisible forces guiding physical change, an idea that indirectly influenced his later understanding of gravity and motion. His alchemical notebooks show him trying to identify these deeper causes. One of Newton's most unusual experiments involved the study of color and light, long before he publicly released his famous findings. His notebooks contain early descriptions of experiments with prisms, reflections, lenses, and refractions. He carefully documented how beams of light behaved when passed through different materials or angles. While these experiments eventually led to his discovery that white light is composed of a spectrum of colors, the notebooks reveal many tests and trials that he never published. Newton often explored ideas for years before revealing them to the world, and the notebooks show the raw process: uncertainty, corrections, failures, and new insights. Another surprising part of Newton's private experiments involves his interest in the human senses. For example, in one notebook, he recorded a controversial experiment in which he pressed a blunt needle against his eye to observe how pressure created patterns of color and light. He believed that understanding the behavior of light required understanding how the eye perceived it. While this experiment is often described in dramatic ways by modern writers, Newton's intention was not harmful. He simply wanted to study perception and optical mechanics with the same intensity he applied to every other topic. His notebooks show a mind willing to push boundaries to gather first-hand evidence. Alchemy occupies the largest portion of his experimental notes. His notebooks contain recipes written in symbolic language, descriptions of chemical processes, and instructions gathered from ancient texts. But Newton did not simply copy traditional alchemical writings. He modified, tested, and corrected them based on his own observations. He melted metals, distilled liquids, tested reactions, and monitored color changes, documenting every detail. His notebooks often include combinations of metals such as gold, silver, mercury, and lead, along with mixtures of salts, acids, and mineral powders. The purpose of these experiments was not literal gold making, as is often mistakenly assumed. Newton was searching for the fundamental principles of matter, what caused substances to attract, combine, separate, or transform. Alchemy, in his view, was a path to understanding the secret mechanisms governing the natural world. His notes show a scientist trying to discover the hidden structures of reality, long before modern chemistry existed. Newton's notebooks also reveal his obsession with precision. He measured temperatures, timed reactions, and noted even the smallest changes in texture or color. He sometimes repeated the same experiment several times to confirm his results. His obsession with accuracy laid the foundation for the modern scientific method, even though many of his notebooks remained hidden. Beyond chemical and optical experiments, Newton also recorded investigations into natural phenomena such as heat, motion, sound, and magnetism. He studied how heat traveled through metals, how objects resisted motion, and how vibrations produced sound. Many of these notes were stepping stones to his groundbreaking physical laws. His notebooks show a scientist slowly constructing an interconnected view of nature long before he presented it in organized form. Another remarkable feature of Newton's notebooks is their emotional intensity. They reveal not just a scientist, but a deeply curious human being who felt compelled to uncover the truth behind everything he observed. His handwriting often shifts between neat and hurried, showing moments of excitement or sudden new ideas. Sometimes he crossed out entire sections and replaced them with improved explanations. Other times he wrote long reflections about what he thought nature was hiding from him. These notebooks also demonstrate that Newton did not separate science from imagination. He experimented not only with chemicals and prisms, but also with theoretical ideas about forces, atoms, and cosmic structures. His imagination was as active as his rational mind, and he allowed both to guide him. This combination of creativity and discipline helped him make discoveries that shaped the foundations of modern science. Perhaps the most important lesson from Newton's private notebooks is that scientific genius is not a straight path. Newton made mistakes, tried unusual ideas, and explored directions that seemed odd or impractical to others. But each experiment, successful or not, taught him something. His willingness to explore the unknown, to take intellectual risks, and to test unconventional ideas made his discoveries possible. Sir Isaac Newton is remembered as one of the greatest scientific minds in history, but behind his groundbreaking discoveries was a personality marked by deep isolation, intense privacy, and a working style that kept much of his thinking hidden from others. Understanding this side of Newton is important because it reveals how his personality shaped the way he produced knowledge, and why so many of his ideas remained unknown until long after his death. Newton was not a social person by nature. From a young age, he preferred solitude, spending long hours reading, drawing, or experimenting rather than playing with other children. His classmates often described him as quiet, shy, and intensely focused. These qualities did not change as he grew older. At Cambridge University, rather than joining groups or attending social gatherings, Newton spent most of his time alone in his rooms, surrounded by books and experimental tools. He avoided unnecessary conversations and rarely formed close friendships. His isolation was not caused by fear or dislike of people. It came from the fact that he felt most comfortable when thinking, observing, and working alone. This isolation allowed Newton to develop an extraordinary ability to concentrate. He could spend hours absorbed in a single problem without distraction. Stories about him describe how he forgot to eat, sleep, or respond to people knocking at his door when he was deep in thought. His intense focus enabled him to make observations and discover connections that others might easily overlook. However, this focus also meant he often shut out the world, working in complete secrecy until he felt ready to share his ideas. Newton's secretive working style was partly a result of his personality and partly influenced by the scientific culture of his time. In the 17th century, scientific research was still developing, and many scholars feared criticism or misunderstanding. Newton was especially sensitive to criticism. He believed that sharing ideas too early could lead to arguments, misinterpretations, or challenges he was not ready to face. Because of this, he waited years, sometimes decades, before publishing his most significant findings. For example, Newton studied calculus for many years before releasing it to the public, and even then, he shared only the portions he believed were perfect. He also kept many of his optical experiments private until he had thoroughly tested every detail. This cautious approach slowed the spread of some of his ideas, but it also ensured that what he finally released was polished, clear, and supported by strong evidence. Another reason for Newton's secrecy was his fear of controversy. During his lifetime, scientific discoveries often led to heated debates. In fields like mathematics, astronomy, and natural philosophy, disagreements could damage a scholar's reputation. Newton hated conflict, but once he was drawn into a dispute, he fought fiercely. The controversy over who invented calculus, Newton or Gottfried Wilhelm Leibniz, was one of the most famous intellectual battles of the time. Newton's intense dislike of disputes made him even more cautious about sharing his ideas publicly. He preferred to work quietly, completing his thoughts before anyone could challenge them. Newton's isolation also reflected the way he viewed knowledge. He believed that truth should be discovered through deep, personal study rather than public discussion. He trusted his own reasoning more than the opinions of others. Even when he worked with fellow scientists, he preferred to communicate through letters instead of face-to-face conversation. His letters were often long, detailed, and precise, showing how carefully he chose his words. This carefulness made him a respected scholar, but it also reinforced his habit of keeping intellectual distance. One of the most revealing aspects of Newton's secretive working style was the huge amount of material he never published. After his death, scholars discovered thousands of pages of notes, drafts, diagrams, and essays that he never shared with the world. These writings covered topics such as alchemy, theology, history, mathematics, physics, and astronomy. The sheer volume of unpublished work shows how much he preferred private exploration over public recognition. Newton did not pursue knowledge for fame or praise. He pursued it because he believed that understanding the world was a duty, a responsibility given by nature and the Creator. His isolation also influenced his relationships. Newton rarely formed close friendships, and when he did, they were often fragile. His intense personality, combined with his high expectations, sometimes led to misunderstandings. He could be warm and generous when he trusted someone, but distant and guarded when he felt misunderstood. He once had a falling out with his close friend and collaborator, the philosopher John Locke, over a small misunderstanding that Newton interpreted as betrayal. Although they reconciled later, this incident shows how emotionally intense and sensitive Newton could be. Despite his challenges with social interaction, Newton was not hostile or unfriendly. People who worked with him described him as polite, calm, and thoughtful. He simply preferred to live inside his mind, where he could ask questions, build theories, and explore ideas freely. His quiet personality helped him remain focused in a world filled with political conflict, social expectations, and intellectual competition. In many ways, his ability to withdraw from society protected his creativity. Newton's isolation also played a major role in his religious and philosophical studies. He spent countless nights reading ancient texts, comparing translations, and analyzing symbols. This work required patience, concentration, and long hours of uninterrupted thought, something his isolated lifestyle allowed him to achieve. The privacy gave him the freedom to explore ideas that were unconventional or politically sensitive. Many of these writings, especially his theological studies, were too controversial to publish during his lifetime. His secrecy protected him from criticism and allowed him to develop ideas without fear. Even when he became a public figure later in life, as the head of the Royal Mint and later as president of the Royal Society, Newton remained private. He carried out his responsibilities with seriousness and discipline, but he never became a social leader or a public speaker. He continued to work quietly, often writing late into the night. People admired him, but few truly knew him. His mind always seemed to be elsewhere, focused on problems no one else had considered. Newton's isolated personality and secretive working style were not weaknesses. They were part of the unique structure of his genius. His solitude allowed him to think deeply, avoid distractions, and pursue ideas freely. His secrecy helped him refine his discoveries until they reached exceptional levels of rigor. While this approach sometimes prevented others from building on his work quickly, it also gave his ideas a strength and clarity that shaped the future of science. Today, Newton's life reminds us that every great thinker has a personal way of working. Some thrive through collaboration and discussion. Newton thrived through solitude and silence. His isolation was the environment where his genius grew, and his secretive working style was the method through which he shaped some of the most important ideas in human history. One of the most defining features of Sir Isaac Newton's scientific life was the extreme caution with which he guarded his discoveries. Unlike many scholars who shared their ideas openly as they developed them, Newton preferred to keep his theories private until he felt they were completely proven, perfected, and unshakable. This careful, almost protective habit shaped the way the world learned about his discoveries and influenced the entire culture of scientific research. Newton lived in a time when scientific ideas were often criticized harshly, debated aggressively, and sometimes rejected without proper understanding. For someone like Newton, introverted, sensitive, and intensely perfectionistic, public criticism was not just unpleasant. It could disrupt his concentration and affect his research. Because of this, he developed a working style based on secrecy, privacy, and complete control. He wanted to release ideas only when no one could question their foundation. One of the best examples of this trait is Newton's discovery of calculus. Newton began developing the foundational ideas for calculus in the mid-1660s, during a period when Cambridge University was closed because of the plague. While isolated at his family home, he worked intensely on problems related to motion, change, and the behavior of curves. By around 1666, he had already created the core principles of what we now call calculus. Yet despite making one of the most important mathematical breakthroughs in history, he told almost no one. Newton waited decades before sharing his methods, and even then he revealed them in a limited, careful way. Why? Because he believed that releasing an idea before it was completely organized and defended could lead to misunderstandings or unnecessary debates. He feared that premature publication would give critics a chance to attack small imperfections, which would distract him from deeper research. His caution was so extreme that when another mathematician, Gottfried Wilhelm Leibniz, published his own version of calculus, Newton still held back his full explanation. This later led to the famous calculus dispute, a controversy that might not have been so intense if Newton had published earlier. Another major example of Newton guarding his discoveries is his work on optics. Newton performed a wide range of experiments with prisms, lenses, and light, discovering that white light is composed of a spectrum of colors. This was a revolutionary idea that challenged long accepted beliefs about light, but even after making the discovery, he hesitated to publish. When he finally did release his findings, he faced criticism and questions from other scientists. The experience frustrated him deeply, and he withdrew from public scientific debate for years. This moment shows how strongly Newton valued certainty. He did not want to share ideas unless he knew that every experiment was repeatable and every detail defensible. He often conducted the same experiment many times under different conditions, writing extremely precise notes before he trusted the results. He believed that sharing incomplete ideas was worse than not sharing them at all. Newton's approach was also shaped by his perfectionism. He rarely felt that a theory was fully complete. Even after publishing his famous book, Philosophiae Naturalis Principia Mathematica, known as the Principia, Newton continued editing, improving, and refining the ideas for later editions. The Principia introduced the laws of motion and universal gravitation concepts that transformed science forever. But Newton did not rush this work into public view. He had been developing and testing parts of these theories for nearly 20 years before the book finally appeared in 1687. During those years of preparation, Newton guarded his manuscripts carefully. He shared drafts only with a small circle of trusted colleagues, and even then, he chose his words with great precision. He wanted to make sure that every mathematical step was correct, every argument clear, and every conclusion logically unbreakable. He viewed scientific publication as a major responsibility. Once a discovery was made public, it would influence the direction of research for years or decades. Because of this, he felt that only the strongest, most complete version of an idea deserved to be released. Another reason for Newton's guarded style was his deep belief that scientific truth should be established through evidence, not authority or popularity. He did not want his ideas to spread simply because he was respected. Instead, he wanted them to stand on their own, proven through experiments that anyone could repeat. This commitment to solid proof inspired his motto, hypotheses non fingo, which means, I do not invent hypotheses. Newton believed that theories must be grounded in observation and mathematics, not speculation. Many of Newton's private notebooks show how he worked through ideas quietly for years before ever mentioning them publicly. He would explore a concept from every angle, searching for contradictions or weaknesses. If he found a problem, he returned to the beginning and tried again. This patient, almost stubborn commitment to perfection was one of the key reasons his published discoveries were so enduring. His careful approach meant that his work rarely needed major revision. However, his guarded style also had consequences. Some of his most innovative discoveries remained hidden for decades. His unpublished manuscripts, discovered long after his death, showed that he had developed ideas about chemistry, motion, astronomy, and mathematical analysis far ahead of his time. If Newton had shared more of his early thinking, scientific progress might have moved even faster. Yet Newton did not see science as a race. He saw it as a lifelong personal quest for absolute truth. This cautious approach also protected Newton from the competitive and sometimes hostile world of scientific debate. He disliked disputes and public disagreements, and avoiding premature publication helped him avoid conflict. Ironically, when he finally did engage in debates such as the calculus controversy, his strong personality made the disputes long, intense, and emotionally draining. Watching how these conflicts unfolded probably confirmed to Newton that his cautious style was necessary. In the end, Newton's habit of guarding his discoveries until they were fully proven reflects both his personality and his philosophy of science. He valued certainty more than speed, quality more than recognition, and evidence more than speculation. His careful approach shaped the way scientific knowledge developed and helped build the foundations of modern research standards. While some thinkers thrive by sharing early ideas and inviting others to help shape them, Newton thrived by perfecting ideas privately until he believed they were unbreakable. His way was different, but it helped produce some of the strongest and most influential scientific theories in history. Sir Isaac Newton is celebrated today as one of the greatest scientists in history, yet many people are unaware that he spent a large part of his life in a completely different world, one of crime, deception, secret investigations, and political responsibility. When Newton was appointed Warden of the Royal Mint in 1696, and later Master of the Mint, he stepped into a role that demanded skills far beyond mathematics. England at the time was drowning in a crisis of counterfeit currency. The economy was unstable, coins were being shaved, clipped, and forged, and public trust in money was collapsing. What the government needed was not just a leader, but a mind capable of solving problems with rigorous logic and relentless determination. Newton, surprisingly, became exactly that person. Newton approached the mint as if it were a giant scientific problem. Instead of sitting in an office signing papers, he dived into the lowest and most dangerous levels of London's criminal networks. He analyzed crimes the same way he analyzed nature, through observation, evidence, patterns, and experimentation. England's currency problem had grown so severe that counterfeiters operated publicly, often in gangs, and used increasingly clever methods to produce fake coins. Many people in authority felt overwhelmed by the complexity of the situation, but Newton saw it as a challenge that required precision and discipline. One of Newton's greatest strengths was his trained eye for details that others missed. Just as he had once tracked falling apples and planetary motion to uncover hidden laws of nature, he now tracked subtle variations in coins, edges, weights, metal composition, and tiny irregularities that revealed forgery. He studied the machinery of the mint, improved coin-making techniques, and introduced tighter controls on metal purity. These were important innovations, but Newton soon realized that improving technology alone would not defeat the counterfeit network. He needed to understand the enemy, predict their moves, and uncover their operations. Newton began to build a network of informants. He walked through taverns, markets, and back streets disguised or unnoticed, gathering information from people who lived close to criminal activity. He interrogated suspects personally, recorded testimonies with extreme care, and cross-checked stories the same way he cross-checked scientific calculations. His notebooks from this period reveal how methodical his investigative style was. He wrote down conversations, tracked inconsistencies, followed rumors, and compared statements until a clear picture emerged. This was not the work of a typical government official. It was the work of someone who approached human behavior like a complex system that could be decoded. Newton's talent for uncovering hidden patterns naturally extended to code breaking. Counterfeiters often communicated using symbols, coded messages, or misleading records. Newton, who had spent years studying ancient texts, alchemical writings, and cryptic manuscripts, was unusually prepared for this. His experience deciphering obscure symbolic languages gave him an advantage few others had. When he encountered coded notes or suspicious records, he analyzed them like puzzles, breaking down the structure, comparing repeated elements, identifying disguised references, and reconstructing meaning through logic and probability. This ability helped him reveal secret associations between counterfeiters, trace the flow of illegal materials, and expose criminal strategies. The most famous example of Newton's investigative mastery was his pursuit of William Challoner, one of the most dangerous and clever counterfeiters in England. Challoner produced fake coins on a massive scale, manipulated government officials, and even tried to publicly discredit the mint so he could take control over parts of its operation. Many investigators had tried to stop him but failed. Newton, however, approached Challoner not just as a criminal, but as a complex problem to be solved. Newton gathered evidence quietly. He built a timeline of Challoner's activities, analyzed his past schemes, and interviewed dozens of witnesses. Some people feared Challoner, while others admired him, but Newton listened carefully to all of them. He reconstructed the criminal network that protected Challoner and identified weak points. He collected letters, tracked money trails, and studied the manufacturing techniques used in Challoner's forgeries. His approach was scientific: gather data, test the reliability of sources, eliminate errors, and move toward a precise conclusion. Eventually, Newton built such a strong case that not even Challoner's confidence or connections could protect him. In 1699, after a dramatic trial, Challoner was convicted and executed, This event marked a turning point in England's war against counterfeiting. Newton's success showed that methodical investigation, combined with a deep understanding of human motives and technical details, could defeat even the most advanced criminals. But Newton's work did not end there. As master of the mint, he continued to reform England's currency system. He supervised the Great Recoinage, an enormous operation that replaced millions of damaged, clipped, or forged coins with new, standardized ones. This effort restored trust in the nation's money and strengthened the country's financial stability for decades. Although this work earned him respect among government officials, Newton remained focused more on accuracy and justice than praise. He was known to spend long hours reviewing records and inspecting coins. Even in his 60s, he performed detailed examinations that most people would have relied on assistants for. Newton's years at the mint also revealed a more human side of him, one that was determined, stern, and committed to fairness. He believed that a corrupted currency harmed ordinary people the most, especially those who lacked the knowledge to detect fake coins. He saw protecting the currency as a moral duty, not just a technical job. This sense of responsibility made him relentless and sometimes feared, but it also made him effective. In many ways, Newton's role at the Royal Mint proves that his genius was not limited to mathematics or physics. His ability to uncover patterns, follow evidence, and think with clarity made him successful in a field far outside traditional science. His investigative work shows that the qualities of a great mind, discipline, patience, curiosity, and logical thinking, can be applied to any problem, even one involving crime and human deception. This secret chapter of Newton's life also helps us understand him more fully. He was not only a thinker who worked with abstract ideas, he was a problem solver who stepped into the real world when needed. His work at the Mint shaped the stability of an entire nation and remains one of the most surprising and impressive parts of his story. Newton showed that the same mind capable of explaining gravity could also bring criminals to justice, decode hidden messages, and reform a broken economic system with precision and determination. Sir Isaac Newton is celebrated as one of the most influential scientists in history, yet much of his enduring legacy extends far beyond the familiar laws of motion, universal gravitation, or the invention of calculus. The lesser known side of Newton, the one shaped by his private passions, reveals a mind devoted not only to science, but also to theology, alchemy, cryptography, history, and philosophy. These pursuits, often hidden from the public eye, not only influenced his personal world, but also left a legacy that continues to fascinate scholars and inspire intellectual exploration. Centuries after his death, Newton's private passions were vast, diverse, and meticulous. While he is commonly remembered for his public scientific achievements, his notebooks reveal an equally extraordinary devotion to subjects that seemed unrelated to physics. For instance, he spent decades exploring alchemy, the study of the transformation of matter, not as a form of superstition, but as a means to uncover the underlying principles of the natural world. Newton believed that matter was governed by invisible forces, and that these forces could be understood through careful experimentation and observation. His alchemical studies, recorded in thousands of pages of handwritten notes, experiments, and diagrams, explored the nature of metals, minerals, and chemical reactions. Although these experiments did not lead directly to modern chemistry, they shaped his methodical approach to scientific inquiry, influencing his insistence on precision, reproducibility, and evidence in all areas of study. Another significant private passion was Newton's interest in theology and ancient wisdom. He devoted enormous amounts of time to studying biblical texts, ancient manuscripts, and historical records. In these writings, he sought to uncover hidden truths about the universe, human history, and divine order. Newton did not simply accept traditional religious interpretations. He analyzed prophecies, calculated timelines of ancient civilizations, and compared translations to reconstruct what he believed were the original meanings of sacred texts. While he kept these investigations largely secret during his lifetime, likely due to the controversial nature of his conclusions, they reveal an intellectual courage and curiosity that went beyond conventional scholarship. Newton's theological work demonstrates that he viewed the universe not only as a physical system, but also as a moral and spiritual order, governed by patterns that human reason could uncover. Cryptography and code breaking were also among Newton's private interests. Before he became famous as a scientist, he trained himself to decipher complex texts and hidden messages. This skill proved invaluable during his tenure at the Royal Mint, where he worked as an investigator against counterfeiters, but it also highlights a lifelong fascination with patterns, symbols, and secret knowledge. Newton approached both natural phenomena and human behavior as puzzles waiting to be solved. His notebooks show meticulous analysis of codes, symbolic language in alchemical texts, and cryptic passages in historical manuscripts. This interest in hidden structures, whether in matter, scripture, or human systems, reflects a mind that sought depth and order in all aspects of life. History and chronology were additional areas in which Newton applied his private passions. He carefully studied the rise and fall of civilizations, the timelines of empires, and the development of ancient knowledge. He believed that uncovering historical patterns could reveal insights into human nature, divine providence, and the principles that govern societies. Newton meticulously cross-referenced historical sources, noting inconsistencies and attempting to resolve contradictions through logic and observation. His historical research was not an academic hobby. It reflected a deep conviction that knowledge, whether physical, moral, or temporal, was connected by universal principles. These private passions had a profound impact on Newton's public scientific legacy. His methodical approach to alchemy and experimentation informed his understanding of physical laws. His study of hidden patterns in scripture and history honed his ability to detect relationships, predict outcomes, and think abstractly. His interest in cryptography and symbolic analysis strengthened his capacity for logical reasoning and problem-solving. In this way, the seemingly separate and secretive pursuits of Newton's private life directly shaped the clarity, precision, and originality of his scientific contributions. Newton's private passions also influenced his personality and work habits, which in turn affected how he approached challenges in science, administration, and public life. He was intensely solitary, preferring to work alone for hours, days, or even weeks at a time. This isolation allowed him to focus deeply on complex problems, but it also meant that much of his intellectual output remained hidden until he was ready to release it. Whether experimenting with chemicals, studying ancient texts, or observing the heavens, Newton's private devotion demanded complete concentration and uninterrupted time. This approach contributed to the depth and rigor of his discoveries, but it also made him enigmatic and difficult for others to know fully. The lesser-known legacy of Newton is also evident in the influence he had on later thinkers who explored the intersections of science, philosophy, and spirituality. His private studies in alchemy and theology inspired generations of scholars to consider the broader implications of scientific work. Newton demonstrated that curiosity and inquiry need not be confined to one field, that rigorous reasoning could be applied to moral, historical, and symbolic questions, as well as physical phenomena. In this sense, his legacy extends far beyond his publicly celebrated discoveries, shaping the intellectual landscape of multiple disciplines. Importantly, Newton's private passions reveal a philosophy of knowledge that resonates even today. He believed that understanding required patience, dedication, and careful observation. He approached mysteries, whether natural or spiritual, as challenges to be solved through methodical investigation. He did not rush to judgment, but instead sought patterns, tested hypotheses, and refined conclusions until they were secure. This approach underscores a timeless principle of inquiry, that genuine understanding arises from disciplined effort, deep curiosity, and a willingness to explore unconventional paths. Another aspect of Newton's private legacy is the sheer volume of material he left behind. Thousands of pages of notes, diagrams, calculations, and reflections remained unpublished at his death. These writings provide a rich source of insight into his mind, revealing the interconnectedness of his private passions with his public achievements. Today, historians and scholars continue to study these manuscripts, uncovering new layers of understanding about Newton's approach to science, philosophy, and the mysteries of the universe. Each discovery from these notebooks highlights the extraordinary breadth and depth of his intellect, as well as the intricate way in which his private passions informed his public contributions. Finally, Newton's lesser-known legacy teaches an important lesson about creativity, curiosity, and intellectual courage. His private pursuits were often unconventional, sometimes controversial, and sometimes misunderstood by contemporaries. Yet he pursued them with unwavering dedication, driven by a desire to uncover truth, understand patterns, and solve mysteries. This dedication to exploration, even in areas that seemed unrelated to his public work, enriched his perspective, enhanced his scientific achievements, and left a legacy that continues to inspire thinkers across disciplines. In conclusion, Sir Isaac Newton's private passions shaped a legacy that is far broader and more intricate than his public reputation suggests. His dedication to alchemy, theology, cryptography, history, and the careful observation of patterns enriched his scientific work and demonstrated a mind devoted to uncovering truth in all its forms. While his laws of motion and theories of gravitation transformed the physical world, his private studies transformed the way we understand the breadth of intellectual inquiry. The lesser-known legacy of Newton reminds us that curiosity, diligence, and the courage to explore the unknown can leave a lasting impact, often in ways that are invisible at first, but become profound over time.